Alright team, Pure Maths 3, we're looking at week 11 of our maintenance, trying to keep up our skills as we prepare for the exam at the end of the year. The first question is an exam question. It's asking us to express this fraction here in partial fractions. Now, we know how to do that. We've done it before in class. So what we're going to say is a times the denominator of the bx plus c plus bx times the denominator of a plus c times the denominator of a ought to give us this 6 plus 6x. You can see this, right? If we wanted to get these as one fraction, we'd cross multiply so that they have one denominator, and that would be how we do it. So I've just got the numerators being made equal to each other. So what I do at this stage is I say let x equal to 2, and if that's the case, you can see that the bx and the c will drop out because 2 minus 2 is 0, 0 times anything is 0, and that would give us 2 times 2 is 4 plus 2, 6a is equal to 2, 6, 12, 18, so a should be equal to 3. And then the next thing I would do is equate the coefficients. Now, we know by looking at the numerator here that there are no x squared terms, but a times x squared and bx times negative x are x squared terms, so they must cancel each other out. So we've got 3x squared from the a's, so we need b to be also 3. And I've done that by equating the coefficients. That's the term for that technique. Now, for C, we can also equate the coefficients. We can consider perhaps how we get x terms. So bx times 2, so that's 2 times 3, 6x. We need 6x altogether up here, which means that c must be 0 because we've already got 6x from the b. So c equals 0, right? So in order to make x terms, we'd have bx times 2. Now b is 3, so 3x times 2 is 6x. We've already got 6x here, so that means that c times minus x must be 0, so c is 0. So we can now express the fractions like this. We've got 3 over 2 minus x plus 3x over 2 plus x squared. Okay? That's the first one. Now, the second one here is we're trying to expand 1 plus 3x to the power of minus 3 and ascending powers of x up to including the term x cubed. So here's what we do. We're going to go 1 is our first term. Our next term is going to be the power multiplied by the second term. The next term is going to be our power. Oh, that should be a negative power, negative 1/3 times negative 4/3. So we drop the power down. We put that over 2 factorial, and we're timesing that by 3x all squared. And then the final term that we need is the x cubed term. So that's going to be minus 1/3 times minus 4/3 times minus 7/3 all over 3 factorial, and then times 3x all cubed. And what does this give us? 1 minus x. This one here, so we get 4 over 9 times 9 cubed. What's that? Let's have a look. 4 over 9 divided by 2 times 9. So I think that gives me 2x squared. And I'll work that all out. And then the last one, oh gee, what is this? Times all over 3 factorial multiplied by, that's 27x cubed. So I'm getting negative 14 over 3 x cubed. Okay, the next one, I've got to solve this logarithmic equation. So first of all, I'm going to write everything in terms of log base 10. So that 2 becomes log base 10 of 100. And then I'm going to use my log rules on the left hand side to get log base 10 of 100x. Then I can drop out the logs, and then I can bring all the x's over to one side, and therefore x is equal to 9 over 99, or 1 over 11. Well, that wasn't so hard, was it? Now the next one, we are using the you can hear my children playing in the background, hopefully not fighting. Sorry. Okay, so we're going to use the addition rule for tan. Okay, and so the way that is for tan, we're going to go tan x minus tan 60 all over 1 plus tan x times tan 60. And then cotangent x is like 1 over tan x, so I'm going to write that, and is equal to square root 3. Now I'm trying to write it in this form here, so I'm going to cross multiply to get one fraction. So I get tan squared x minus, now what's tan 60? Square root 3, isn't it? Hang on. Tan 60 is square root 3. Okay, so then I can rewrite this as minus tan square root 3 tan x plus 1 plus square root 3 tan x. So I've just times this bottom bit by this 1 here, and that's all over tan x plus square root 3 tan squared x, and that's all equal to square root 3. Now all I've done there is I've just made one fraction, so I've cross multiplied. The next line, I'm going to bring the denominator of the fraction across. So hopefully you can see that I've got tan squared x plus 1, because this and this will cancel out, is equal to square root 3 tan x plus 3 tan squared x. Now I'm going to bring everything over to left hand side, or right hand side. So 0 equals 2 tan squared x plus square root 3 tan x minus 1, which is exactly what I wanted to prove. And hence that means I'm going to use this formula to solve for the equation for between 0 and 180. So I'm just going to say tan x equals minus b, so in that case minus square root 3 plus or minus the square root of square root 3 all squared minus 4 times 2 times negative 1 all over 2 times 2. And I'm going to get two values of x, so let's chuck those in and see what we get. Negative square root 3 over 4 plus or minus 3 plus 4, 7. Is it square root? Hang on, 4 2 is 8. 8 and 3 is 11. 11 plus 11 square root 11 over 4. So those are our two values, our tan x for tan x. And therefore, x is equal to the inverse tan of those. So if I do inverse tan of negative square root 3 over 4 plus square root 11 over, square root 11 over 4, I get 21.6. And obviously, given the range, that's the only one for that one in the range. Now I'm going to use the negative one, and so just rearrange, just change from my calculator that to a negative. And this gives me negative 51, which is obviously not in our range. But if we add 180 to that, we should get something that is in the range, which is 128.4, because the period of a tan graph is 180. So those are my two values here. Okay, the next one I'm going to differentiate. I'm using the product rule for this. So I'm going to say u is equal to x plus 1. I'm going to say du dx is equal to 1. I'm going to say v is equal to x minus 1 all to the power of 1/2. And so dv dx is going to be equal to, using my chain rule, 1/2 x minus 1 to the power of minus 1/2. So far so good. Now I can plug that into my formula. So dy dx is, or the gradient function is going to be u times dv dx, so it should be 1/2 x plus 1 times x minus 1 to the power of negative 1/2 plus x minus 1 all to the power of 1/2. And now we can rearrange that. You can see that we can take this out of the whole thing. Right, that's to the power of 1/2, so we can write it like negative 1/2, so we can write it like this, and that gives us 1/2 x plus 1 plus 1. Okay, that's another way of writing that. And then all up, we end up with, we can put that 2 at the bottom, so we get 3 plus x over 2 square root x minus 1. I think that's right. Let's just go back a bit. I may have made a mistake here. So we get, excuse me, 1/2 x plus 1/2 plus 1 all over square root x minus 1. Yeah, I think, so we get 3 over 2 plus half x all over square root x minus 1. Yeah, and I think we can rewrite that as 3 plus x all over 2, right, times x minus 1. I think that's correct. Let's move on. The next one, I've got to use the information for the algebra question to show that, okay, which one was the one in the algebra question? Okay, let's copy that. We're going to integrate this. Whoops, what am I doing? Okay, for some reason that's just stuffing up. Let's go back in. Okay, so we're going to integrate this. Okay, and we're doing it between 1 and minus 1. So if I integrate the first one, you can see that I'm going to get minus 3 ln 2 minus x. And then the next one, now how are we going to get this? So it's also an ln, but I think we want a 3 over 2 ln, and what we've got here is this 2 plus x squared. And you can see how that would work, because if you differentiate this bit here, you get 2x, and if you times it by the 3 over 2, you get 3x, which is what you want on top here. So that's fine. And we want this between 1 and minus 1. Now let's apply those. So when we apply it, what do we get? So we get minus 3 ln, so our first bracket, 2 minus 1, so ln 1, plus 3 over 2 ln, and that would be 3. That's our first bracket. Subtract. Now we do our next bracket. Negative 3 ln 2 minus 1, so that's 3, plus 3 over 2 ln 3. Now you can see, hopefully, this first term is 0, so that's gone. And then you've got 3 over 2 ln 3 take away, another 3 over 2 ln 3, which leaves you with minus 3 ln 3, so that's positive 3 ln 3. And there's our answer. Okay, so for the next one, we're trying to show that for this equation here, that the root lies between x equals 1 and x equals 2. So what we do here is we bring everything across to one side. So we can go x minus 10 over e to the 2x minus 1 equals 0. And then we just chuck in some values. When x equals 1 and we plug that into the formula, what do we get? 1. 1 minus 10 over e to the 2 minus 1, and we get a negative number. And then we apply that again when x equals 2, x minus 10 over e to the 2x minus 1. What does that give us? Equals a positive number. Sign change. Therefore, root lies between 1 and 2. Now, show that if a sequence of positive values given by the iterative formula x blah blah blah, then it equals 1/2 ln 1 over blah blah blah, then it converges at alpha. Okay, so what we're going to do is we're going to try and prove that we can get from here to this equation here. That's what we're trying to do. So I'm going to just put in alpha for x. And what am I going to do? I'm going to multiply both sides by 2. Then I'm going to make both sides in terms of ln, so that's 2 alpha. Now I can get rid of the ln's. E to the 2a equals 1 plus 10 over alpha. And now you see we're getting really close. E to the 2 alpha minus 1 equals 10 over alpha. And I can multiply. So alpha equals 10 over e to the 2 alpha minus 1, and that's exactly what we wanted to prove. That's that bit there. Okay. Now use this iterative formula to determine alpha correct to 2 decimal places. So we're using this formula here. Okay. So step 1, we're going to go x, and I'm just going to start off with 1.5, or alpha equals 1.5. Whoops, because that's what I want. Alpha equals 1.5, that's alpha 1. And then I chuck into my calculator. So this is how I'm going to write it. I'm going to go 1/2, so I go 1.5 on my calculator, equals, and that will store it in the answer. And then I can type this on my calculator, ln 1 plus 10 over ants. And then I can just keep on clicking equals for each new term. So what does this get me? Ln 1 plus 10 over ants. Okay, so my second value is 1.0. Is that right? try that again. 3 over 2 equals, so 1 over 2 ln 1 plus 10 over answer. Okay, so alpha 2 equals 1.0. What are we going to? 4 decimal places. 184. Alpha 3 equals 1.1906. Alpha 4 equals 1.1203. Alpha 5 equals 1.1476. Alpha 6 equals 1.1368. Alpha 7 equals 1.1410. Alpha 8 equals 1.1394. Alpha 9 equals 1.1400. Alpha 10 equals 1.1398. Alpha 11 equals 1.1399. You can see we're getting very close here. Alpha 12 equals 1.1398. Alpha 13 equals 1.1398. Alpha 14 equals 1.1398. Okay, so I can now give my result of to 2 decimal places. Alpha equals 1.14 to 2 dp. And we are done. Well, I hope that's been helpful. If you have any questions, let me know, and take care.